Okay, there we go. So remember, our zeros represent where our graph crosses the x-axis. And where our graph crosses the x-axis, what are all the y-coordinates? 0. So if I'm writing the zeros as a point, it's going to be the point -2, 0, and 2, 0. All right, so we checked for domain, we checked for the vertical asymptote, we checked for zeros. What's next?
Slant.
Before slant.
Horizontal.
Horizontal. Can we have a horizontal and a slant asymptote? No, it's one or the other. Could we have neither of them? Yeah, we could have neither slant or horizontal, but we cannot have both. So I'm going to check for the horizontal asymptote. And to find the horizontal asymptote, we take the limit as x approaches plus or minus infinity of our function, which is x squared minus 4 over x. All right, how do we take a limit when we're approaching infinity? We take the biggest variable on top with its exponent and coefficient, which is
X squared.
just x squared, and the biggest variable on the bottom, which is just x. We simplify. X squared divided by x is x. Now you plug in the infinity for x. When you plug in the infinity for x, what is the limit? Infinity. So if the limit is infinity, that means there is not a horizontal asymptote, there is a slant asymptote. So we're going to say the limit has to be infinity for it to have a slant asymptote. So we're going to say slant asymptote, which I represent as SA, since limit as x approaches plus or minus infinity of our function is infinity, there will be a slant asymptote. Okay, I'll let you catch up. Okay, so now that we know there's a slant asymptote, we have to find the slant asymptote. The way we find the slant asymptote is you actually divide the function. So our function, f of x or y, is equal to x squared minus 4 over x. You are going to divide this so the numerator goes inside of the house, x squared. And we want to account for every exponent, so I'm going to say x squared plus 0x minus 4. And then what's in the denominator goes outside the house. And now we divide. X times what gives us x squared? X. X times x gives us x squared. So x times x is x squared. And then we subtract. What happens with the x squareds? They cancel. So now I'm going to bring down -4. Can x times anything give us -4? No. So what does -4 represent?
Remainder.
This is the remainder. I don't care about the remainder. So we're going to say don't care about remainder. So then what do we care about? I'm going to put a star here. We're going to say the equation of the slant asymptote will be y equals whatever the quotient is. So in this scenario, our quotient is just x. So the equation of the slant asymptote here will be y equals x. Can we ever cross a vertical asymptote? No. Never. Can we cross a horizontal asymptote? Yes. You can also cross a slant asymptote. So now that we have the equation of the slant asymptote, now we have to see, does it cross the slant asymptote? And the way you figure out if it crosses, you're going to set your function equal to the slant asymptote. Should I give you guys a minute to catch up? Okay, so my function is x squared minus 4 over x, and I'm going to set it equal to the slant asymptote. Well, what's the slant asymptote? X. So I'm going to put this over 1, and then I'm going to cross multiply. X times x is x squared. X squared minus 4 times 1 is just x squared minus 4. We're going to go ahead and we're going to try to solve. So I'm going to subtract x squared on both sides. But what happens when I subtract x squared on both sides? They cancel on both sides. So I'm left with 0 equals negative 4. Is this a true statement? No. Was I able to solve for x? No. So does it cross? No. Does not cross slant asymptote. All right, so now we are ready to sketch. Let you catch up before we sketch. You ready? Okay, so now we're sketching. All right, the first thing we're going to put in our graph is our vertical asymptote. We have a vertical asymptote at x equals 0. So I'm drawing my vertical asymptote right here at the y-axis. There's my vertical asymptote. The next thing I want to graph is my slant asymptote. Well, if you guys remember, the slant asymptote was y equals x. Well, if we're thinking of this as a line, shouldn't it be y equals mx plus b? So this is going to be y equals 1x plus 0. And y equals mx plus b, what does b represent?
The height of the...
Good. It represents our y-intercept. What does the m represent?
Slope.
Slope. And we always write slope as a fraction. So my slope is 1 over 1, and my y-intercept is 0. So when we go to graph the slant asymptote, I'm starting my line at the y-intercept, which is 0. And then I'm going to make other points according to my slope. So my rise, slope is always rise over run. My rise is +1, my run is +1. So we're going up 1, right 1, up 1, right 1, and we're going to keep going because I don't know exactly how big of a graph I need, but I'm going to make it substantial enough that I see what's going on. And then instead of going up 1, right 1, to get the other part of my line, I'm going to go down 1, left 1. And because this is also an asymptote, it's not part of my line. It is my graph. It is dashed. All right, so we graphed our vertical asymptote. We graphed our slant asymptote. We had zeros. Let's plot those points. What was 1 0 that we had? Yep. +2 and -2. Guys, all I need are points to the left of the vertical asymptote and to the right of the vertical asymptote. Do I have points to the right and to the left of the vertical asymptote? Yes. So do I need to test any more points? No. No. So now what we do is we use the asymptotes to guide our graph. So what do I mean by that? I mean by, yes, yes. So I mean we're going to hug the slant asymptote, and then I'm going to hug the vertical asymptote. So it looks something like that. And then on the other side, we're doing the same thing. I'm going to hug the slant asymptote, and then I'm going to go through and hug the vertical asymptote. So it looks something like that.
Can I see it on like a calculator?
If I change screens, it will stop recording, but what I can give you is my graphing calculator so you can see it. I didn't record in the program that lets us change screens, but I could type it in for you. Okay, guys, we ready for the next one?
What do we call these again?
Graphing rational functions.
I thought they had like a special name.
Oh, no, these are all just rational functions.
Okay,
all right, next one. This graph is going to be a little bit different. So here we have y equals x squared minus 3x minus 4 over x plus 3. So same thing we've been doing. We're looking for the domain first. So for the domain, we have to set the denominator equal to 0. So we're going to say x plus 3 cannot equal 0, so x cannot equal -3. Now, for the vertical asymptote, before I set the denominator equal to 0, before I do that, I need to try to simplify. Can I potentially simplify this? Maybe. Let's see what happens. When we have our vertical asymptote, can I factor that numerator? No?
I thought you had to do the FOIL.
Factor? Yeah, that's what I'm saying. Can I factor? Yeah, we can factor. I'm going to get an x minus 4 and an x plus 1. And my denominator is an x plus 3. So I'm trying to simplify, but can I cross anything out when I do that?
Unfortunately not.
No, we cannot simplify. So since we cannot simplify, we then just go straight to setting, once again, our denominator equal to 0, and x will equal -3. Maddie, what's wrong? Why do you look so confused?
I was confused because I thought we were I thought you were doing the top. I thought you were setting the top equal to 0, and I the vertical asymptote you do the denominator.
Okay, good. All right, so we have our domain, we have our vertical asymptote. The next thing we want to do is find the zeros. Maddie, for the zeros, that's when we set the numerator equal to 0. X squared minus 3x minus 4 equals 0. So once again, we're going to factor. So x will equal positive 4 and x will equal negative 1. Now remember, the zeros represent where our graph crosses the x-axis. So how do I write these zeros as a point? It'll be 4, comma, Chelsea, 0, you got it. And then negative 1, comma, 0. These are our zeros. All right, next thing we look for is our horizontal asymptote. So I'll put horizontal or slash because we sort of find them the slant asymptote. We sort of find them the same way. So we're going to take the limit as x approaches plus or minus infinity of our function, which is x squared minus 3x minus 4 over x plus 3. Tell me, what am I putting here to find the limit? X squared over x. I simplify that down to just x, and when I sub in infinity for x, what do we realize? The limit as x approaches plus or minus infinity of f of x is infinity, plus or minus infinity. So does that mean we have a horizontal asymptote, a slant asymptote, or neither? We have a slant asymptote. So now we go on for that. So now for the slant asymptote, we're going to divide. Whatever's in the numerator goes on the inside. Every exponent needs to be accounted for, which it is. And on the outside is the denominator. All right, so this division is not as easy as the last division we did. So x times what gives us x squared? X times x. Now you take that x and you distribute it in to the expression on the outside. So x times x is x squared. X times 3 is a positive 3x. But when we subtract now, don't I have to distribute in that negative? So all the signs become the opposite. So the x squareds cancel, and then I have negative 3 plus a negative 3, which is a negative 6x. Bring down that negative 4. So now we ask ourselves, yes, David?
Wait, what is
Oh, because when you're dividing, let's just do something simple. Like if I'm dividing 3 by 7, we say, okay, well, 3 goes into 7 twice. 2 times 3 is 6, and then what do? You subtract. So that's what we're doing. We're subtracting, but because it's more than one thing we're subtracting, we have to distribute in that minus sign. All right, let's keep going. So now we ask ourselves, well, x times what will give me a negative 6x? X times negative 6. So now we distribute that into the divisor. Negative 6 times x is a negative 6x. Negative 6 times 3 is a negative 18. But because we're subtracting, I need to distribute in that minus or negative sign. So all the signs become the opposite. So the 6x's cancel, and then I'm left with negative 4 plus 12, which is, negative 4 plus 18, which is a positive 14. What does this positive 14 represent? The remainder. Do I care about the remainder? All right, I don't care. So what is the equation of my slant asymptote? Y equals, good, the divisor, x minus 6. So now we found the slant asymptote. What's the last thing I have to check for?
Cross.
Does it cross? And the way we check to see if it crosses the slant asymptote, we take our equation, x squared minus 3x minus 4 over x plus 3, and we set it equal to the slant asymptote. The slant asymptote's not a number. The slant asymptote is an expression. What is it this time? X minus 6. I'm going to put this over 1. And now we cross multiply. So x squared minus 3x minus 4 times 1 is just x squared minus 3x minus 4. But then on the other side of the equal sign, don't I have the quantity of x plus 3 times the quantity of x minus 6? In order to solve this, I have to FOIL. So x times x is x squared. X times negative 6 is a negative 6x. 3 times x is 3x. 3 times negative 6 is a negative 18. So now we have x squared minus 3x minus 4 is equal to, I'm going to combine my like terms, x squared minus 3x minus 18. Now I solve. So I'm going to add x squared on both sides. Oh, sorry, not add. I meant subtract. I'm going to subtract x squared on both sides. And what happens on both sides with the x squareds? They cancel. So now I'm left with negative 3x minus 4 equals negative 3x minus 18. Now I add 3x on both sides, but once again, what happens when I add the 3x? They cancel again. Does negative 4 equal negative 18? No. So does it cross? No. Does not cross. Yeah.
Since we already got the factors at the top, can't we just see that it doesn't equal it because those factors?
You could do that, yeah.
Factors.
Yep, absolutely. Okay, let's keep going now. We ready for the sketch? Anybody still copying this? No? All right, sketch. So the sketch is going to look a little different. All right, so first thing we're going to sketch is our vertical asymptote, which is at negative 3 this time. Then we're going to sketch our slant asymptote. Now remember, our slant asymptote was the equation y equals x minus 6. Well, we know that's a 1x, and we know this should look like y equals mx plus b. So my slope is 1 over 1. My y-intercept is negative 6. So now when it comes to graphing this, we're going to go down the y-intercept to negative 6. 1, 2, 3, 4, 5, 6. This is my starting point. And then we're going to create the rest of the line using the slope. So I'm going to go up 1, right 1. Keep going, up 1, right 1, up 1, right 1. And then on the other way, I want the asymptotes to cross. So on the other way, I'm going down 1, left 1. And if we need to extend the graph, we extend the graph to make sure they cross. All right, so there I got it to cross. And I'm drawing my dashed line. Okay, did we have any zeros?
Yes.
Yeah, we sure did. What zeros did we have? Good. We had a positive 4. 1, 2, 3, 4. And we had a negative 1. All right, so these are 2 points that actually help us figure out what's going on to the right of the vertical asymptote. So remember, all we do is let it lead the way. So I'm going to hug the slant asymptote, turn around, then hug the vertical asymptote. So it looks something like that. But both those points that we had, weren't they both to the right of the vertical asymptote? The 2 points, the 2 zeros, they were both to the right. Did we have any points to the left? No. Remember, the vertical asymptotes guides us. We need everything, we need a point in every direction of an asymptote. So I have the points to the right, but I need something to the left. So if my vertical asymptote is at, what was this? Negative 3. Can I do negative 4? Yeah. So I'm going to test the point, or test the x-coordinate. I'm going to plug in to x squared minus 3x minus 4 over x plus 3. I'm going to sub in negative 4. So I have negative 4 squared minus 3 times negative 4 minus 4 all over negative 4 plus 3. So then we're going to have y is equal to 16 plus 12 minus 4 over negative 1. So we will have y is equal to 24 over negative 1, which is negative 24. So this is the point negative 4 comma negative 24. I'm obviously not going to plot negative 24, right? But do we agree if we're going negative 4 and then to negative 24, we're down in this area right here between where the 2 intersect? So since I know that the point negative 4, negative 24 is in that area, all I have to do is follow my asymptotes to get an idea of what that looks like. Okay, we are going to stop for today. Your homework is going to be to just graph 1 problem. That's it. That's your homework, just to graph 1 problem. You could do it now and be done.